The broadcast is now starting. All attendees are in listen-only mode.
Well, good afternoon, everybody, and welcome to the final session from Smart Vision Europe today, where we're looking at IBM SPSS Modeler. So this is a series of webinars that we run on a fairly regular basis. If you're familiar with how it works, you'll know that we normally spend about 10 or 20 minutes talking through the topic and include a demonstration and then finish off with a few closing remarks. Today we'll be demonstrating IBM SPSS Modeler and showing you a few examples of how to apply that software. My name is Darth Quinn. I'm an analytics consultant and I'm joined online today by my colleague Rachel. And Rachel will be just fielding questions and making sure everybody's logged in correctly as we're going along. If you haven't joined any of these sessions in the past, then there's a few FAQs we might want to deal with. First of all, that we record these sessions so you can listen to them afterwards. And secondly, there are only a few slides I'm showing here, but we always email out a PDF copy to you after the session has ended. And with regard to arranging reruns for colleagues, if you think it's particularly useful or pertinent to your colleagues and you want us to run a private session for you, then it may be possible for us to do that. So just ping us an email afterwards or ask using the chat facility. All of the lines are muted at the moment, so we can't hear you. Hopefully you can hear us. But if you want to ask questions, then use the chat facility, and Rachel will probably field them as we're going along. If we run out of time, if we're unable to answer any of your questions, then obviously we'll follow up with you offline. And of course, you're able to ask us questions just by sending us an email offline anyway about anything that you're saying here or anything that we haven't talked about that you're particularly interested in. So we're going to talk about SPSS Modeler. And that's one of the pieces of technology that we support. We're actually a premier IBM business partner specializing in the SPSS Advanced Analytics Suite. We've also a gold partner at SAS, so we were earlier today doing a session on SAS Visual Analytics. And we're also an exclusive partner for Blue Sky Statistics, who provide a kind of entry-level analytics tool based on the open source R language, if you've heard of that. So we're spread across lots of different technologies with a strong emphasis on advanced analysis. That means predictive analysis, data science, machine learning type analytics. We're a relatively small organization, but our team is made up of people who have about 15 to 25 years of experience working within the analytical software industry. And I've personally worked for SPSS, IBM and SAS. So we're fairly well placed to talk with a fair degree of authority about these tools and about their application and how people make use of them. And Modeler is a nice tool to talk about. It's a nice program, nice package to talk about because it's very comprehensive and it's got lots and lots of use cases, lots of areas where it's actually been used in different sectors and different applications across the world. It is generally regarded as a predictive analytics or a data mining workbench. Predictive analytics is a term that's still used fairly heavily within the advanced analytics industry. And just so that you're aware of that, I mean, if you look it up on Wikipedia currently, it's a banner term that encompasses things like classical statistics, so statistical procedures that you may have used before, but it also includes things like data mining and machine learning. And there's a strong emphasis on analyzing historical and current data to make predictions. It's not actually always about predictive prediction per se. There's a lot of times when predictive analytics includes things like segmentation work or anomaly detection, but certainly a very strong theme is predictive analysis, and that's one of the things we'll be looking at in this example, predictive modeling. We should bear in mind, though, that not all of the data that we're working with is always structured data. It's not always quantitative data. Sometimes it's unstructured in the form of open text, documents, video, audio, images, that type of thing. So this is increasingly common sources of data, and in some of those situations, particularly things like open text, we might well use Modeler to mine open text, and it does a pretty good job of that. And it also allows us to do things like what-if scenario analysis. We're not going to cover that today, but suffice to say that if you go onto our website, there are some videos there that look at things like text mining, that look at the record examples of scenario planning or what-if analysis if you want to see how Modeler is applied in those areas. Okay, so predictive analytics is different from BI or MI. This isn't a tool, this isn't a BI or an MI tool. It's not about creating dashboards or lots of tabulation. It's got some charting facilities, but it's not its main focus. As I say, it's not always about prediction per se, but the key thing here is that Modeler, being a predictive analytics package, always creates new data that didn't exist before, and these data take the form of columns that record things like estimates that a model has uncovered, or probability values, or forecasts, or recommendations, or propensity scores, or likelihood values. And it creates this data, and it's this data that it creates using these advanced modeling tools which allow us to enhance our decision making. And we enhance our decision making by incorporating these data back into operational systems or insight systems. Operational systems would be things like maybe a campaign management system where we've used Modeler to help us predict who's most likely to respond to a particular offer, or a retention model that's going to indicate people who are most likely to cancel a subscription, or maybe it's something like an application where we're looking at machines rather than people. So maybe we're looking at asset recovery or asset failure. So we're actually sending these forecasts, these probabilities, recommendations out into something like a workforce management system. And with regard to insight, well, there's no reason why we can't take propensity values or probability of churn, or likelihood to renew a contract, or likelihood to visit a store again, or recommend to a friend, and reincorporate that into our existing analytical tools, such as the BI and MI platforms like Cognos or Tableau or Business Objects, or anything that you happen to be using. There's no reason why we can't take the results of a model and incorporate that back into it. And it's one of the things that we try to encourage our customers to do, because it's a way of us showing the results of a model and surfacing that to stakeholders and to key decision makers within the organization. So why do people choose SPSS Modeler? Well, it's a very powerful, it's fairly industry-leading analytics platform. It's it's an end-to-end platform, and platform is the correct term for it really, because it does extend out into lots of other sister applications. You may have heard of applications, you may not have heard of applications like collaboration and deployment. You may have heard of the statistics tool, the SPSS statistics tool, which it has integration points with. It may well be that you want to integrate with existing algorithms that are available on your data warehouse, maybe using Oracle or IBM DB2, or maybe you're using something like Netezza or anything like that. So it's very much a hub within a platform. But that being said, you can have it running as an absolute standalone client tool, which is the method that we're using here. So it's a one-stop shop for things like being able to read and consolidate data. You've got lots of data, let's assume, in lots of different locations across the parts of the business. Maybe they're in Excel, maybe they're in a warehouse, maybe the data takes the form of a text file. So Modeler is pretty good at reading that data, bringing it in and consolidating it. It's also very good at manipulating and cleaning the data and getting it into shape so that you can actually do some analytics with it. So uncovering patterns, building predictive models, and incorporating the results, integrating the results with operational and reporting systems, as I said earlier on, being able to send these scores back out directly to a database or to a system that's going to be able to read the results of our analysis. So it's pretty good at that sort of stuff. That's one of the reasons why people use it, because they can cover pretty much everything they need to do within the life cycle of Predictive Analytics project, all in one location, without having to drop out into code, without having to use supplementary packages. Now, if we were to boil it down into three typical areas where Modeler is used, it's certainly one of the most important areas is things like prediction. So that prediction takes the form of predicting a numeric value, the amount of money people are going to spend, or category membership, the category or an outcome of some sort, but people are likely to respond, as I say, to a mail shot, people who are likely to redeem a voucher, or people who are likely to recommend us to a friend. But then on the non-predictive side, we have things like grouping similar cases together. So this would be cluster analysis. There's at least 3 cluster engines within Modeler that attempt to find similar cases, and associated with that would be things like anomaly detection, where you're trying to find unusual cases. Then we have things like association analysis. We're going to look at an example of that, where we find events that occur together, particularly things like purchases, products that get purchased together, but also things like failure. You know, when you're looking at assets and part replacement, what sorts of parts tend to get replaced. So association analysis is another key area of Modeler. And that's not including, in this list, other procedures like forecasting, for example, or text mining, or simulation of data, that type of thing. There's a lot of miscellaneous procedures that are also within the Modeler package. Okay, so why IBM SPSS Modeler? One of the other areas is that it creates very rich interactive graphics that enable us to do things like data filtering, field creation, recategorization. In other words, one of the things that makes Modeler quite nice to work with is the fact that when you do a chart, you can get it to create new fields for you. And in fact, we've just put a video on our website that goes through about 7 different it's called 7 Secrets of Modeler. It goes through about 7 different aspects of Modeler that, that kind of point out useful procedures, and one of these is this business of being able to use the charts and the output to create new fields. I'll allude to it when I'm doing a demonstration in a few moments. So reading, consolidating data from multiple formats simultaneously is definitely a key aspect of Modeler. Here we are, we're not reading them in, we're not turning the data into our native file. We're not turning them into SPSS file types. We're actually reading the data as it is. And it might be that we're reading data from a database, it might be reading data from an Excel file, it might be reading data from XML format, or from native SAS files, or whatever, but we can read them all without having to turn them into anything, without having to duplicate the data, without having to send it into Modeler's own internal database. Because Modeler doesn't have its own internal database, it doesn't have a native file format, it just reads the data as it is. But the other thing is that it's very easy to build predictive models very quickly. In fact, it's got this automated modeling capability, which we'll talk about in a few moments, and it's very useful because it will try out lots and lots of different algorithms and then choose the best one for that particular situation. And as I say, exporting the predictions directly to third-party formats, well, you can do the entire end-to-end process here and send the data out, as a report or as a table to a database if you so wish. So let's skip out and we'll have a little look at a specific example of Modeler. Which version am I using here? I am using version 18, I believe, in this. Version 18. Version 19 I would expect would be out at some point in the first half of this year. I'm not sure when IBM intend to ship it, but it's due to be shipped at any point. So if we look at Modeler here, what are we looking at? Well, the first thing is that we're looking at a system that allows us to describe the analytics as a process. So it starts as a process where we have data that we can read in various formats. So it might be an SPSS file, it might be a Cognos data set, it might be Excel, it might be a SAS file, it might be XML. We can read these data sources and they all appear as little circles. Okay? And having done that, we might do something to them. We might select one of these data sources and say, well, I want to sample the data, and then I want to aggregate the data, and then I want to merge it with this file down here. So I'm merging the data together, and then place that, merge these different files together, etc., etc. And as we're doing this and merging them together, we're kind of building up the whole process. We might then need to sort the data. We might then need to create new fields, derive new fields, You can see these little symbols are coming in here that do different things to the data. The reality is that Modeler really doesn't expect much of the data that you got. It kind of assumes that the data you've got is probably pretty messy, and it probably hasn't been collected with analysis in mind. It's probably been collected with something else in mind, with billing in mind, with marketing in mind. And therefore, it's very important to have a workbench or a tool that's going to allow us to really get to grips with data that's pretty messy and clean it all and get it into shape. And normally in your first project, as you're working on a particular application with tools like Modeler, one would expect to spend about 60% of your time just trying to get the data into shape. Once you've done that, you can then hit it with all sorts of analyses. So let's not labor that point too much. Let's have a little look at a stream, a very simple Modeler stream here. And in this first example, we're going to look at reading some data from a database. It's in a SQL Server database. We're going to get an overview of the data, and we're going to interact with that data to show how we can how we can get charts to create new fields for us. And then we're going to do what's called an association analysis. We're going to try and find which products get sold together so that we can identify opportunities to, in this case for this retailer, to present products or offer products to people that are relevant to them. A bit like one would do when you go on to Amazon, for example, and it recommends a product to you based upon the purchase history of similar purchase histories from other people. So here we have the home goods data set. You can see it's just a little circle here with SQL written in the middle. That doesn't mean it's a SQL server, it just means it's a database. I can edit it. It's just called basket here. If I hit preview, one of the nice things about Modeler is that if I hit preview, it always previews the top 10 rows or the top 100 rows, whatever. I've asked for the top 10 rows here. Just gives me a little preview of the data there so I can see it in the background. And if I wanted to select, let's say, males who have purchased a certain product, let's say males who have purchased gardening products, I could just highlight those two cells and get Modeler to go and create what's called another select node for me. That just filters the data, and it just saves me the trouble of actually typing that in. And everything downstream of that now is males who've bought this particular product group. So they're all, as you can see, they're all male, gender M, and the product group is gardening, all T for true. So right away out of the box, it's very easy to filter the data and say, well, I want to get rid of certain groups, so there's a certain subset here that I really want to work with. But to get an overview of the data, if I right-click on this little box here, which indicates that it's an output node, this little box gives me an overview of the data. It shows me all of the different fields in the data. It's very, very useful because it tells me the minimum and maximum values. It's very good for spotting errors in the data, particularly if you get things like minus numbers and age. It tells me how many valid cases there are. You can see here this is very, very clean data, but this number might vary depending on the missing data. And in fact, within this little procedure here, I can actually go into the quality node, and it will do all sorts of clever things like estimating what a missing value should be, or dealing with outliers and extremes, or cleaning up the data based upon patterns of missing values, and so on and so on. So I can do all these clever things in there. If I go back to just the audit node here and look at something like income and double click on that, it just opens up a little chart for me. And again, I could use my generate procedure up here. I could slice this manually, so I could create little slice points here and say I want to break them here, and I'll just rename this band here into middle, middle income or medium or something like that. I could just call it medium, and I could call the other groups here, low and high. So we could rename this to low, and this one here to high. And I'm just doing this because this is the sort of thing you might do when you're playing with the data, when you're trying to get it into shape. If I then went to generate, I could go generate derive node. That would generate a little node for me, which would create these 3 different groups for me, which are low, medium, and high. And if I hit preview at the top here, of course, it creates this new field called band, and they're either low, medium, or high in terms of their income. So very, very simple there to create new fields on the fly. On top of this little node here, I've got this additional triangular node, and if it's a triangle, it means it's a chart of some sort. If I run this particular chart, what we'll find is it's a way of illustrating the relationships between the different values there within the data set. Let's have a look at the data set again, just so that we can preview it. You can see the data set's made up of things like the amount of money people spent, the method that they used, and whether or not they're male or female, whether or not they're a homeowner. But we've got a whole bunch of categories here which are just trues or falses. There could be ones or zeros. And they're simply telling us for these customers, of which there's like 1,000 of them, have they ever made a purchase in the electricals department? Have they ever made a purchase in the home office department, or bedroom, or living room, or kitchen? And let's say this goes back about 6 months worth of history. So that when we illustrate that as a chart, it shows it to us as what's called a web plot. And the web plot is just showing us the interrelationships between each of these products. So here, for example, we can see that a thick line between kitchen and dining indicates a strong relationship between kitchen and dining. There is a three-way relationship here between gardening, home office, and electricals. And there's also a relationship here between living room and textiles. And in fact, if we hover over these, it will in fact tell us how many cases are coinciding with these two values. So if I pick a weak one, let's pick a weak one. Here's lighting and heating here, kitchen and lighting and heating. There's only 56 links there, whereas here there's there's 173. So that's why that's getting a thicker line. And I can control how many cases I show or how many records I want to include in it, and I can even define what represents a strong or a weak link. So I can say, okay, here's a strong link, here's a weak link, and I can play around with these sliders and filter out the weaker relationships. I could pick one of these relationships, right-click on it, and say, generate a select node for that, and that would, for example, create a little node here which would select, as we saw earlier on, people who have bought textiles and people who have bought living room, because let's say that we're particularly interested in those individuals. Okay, so that's a way for me to illustrate this relationship just from the standpoint of insight. If I look at the output here, it's very insightful, it's very useful for me, and I can see obvious affinities here. But if I wanted to use this to actually create a model so that I could make recommendations to the business based upon people's purchase history, or maybe every time the customer comes onto the website, instead of seeing a random image that is shown to them or the latest offer, they're actually shown a product which has a strong affinity with their purchase history. Maybe they've bought stuff in the kitchen department, but they haven't bought anything in the dining department, so maybe we should show them something from the dining department, since there is a strong affinity with that. Similarly here, between gardening, home office, and electricals, a three-way relationship. So how can we kind of operationalize this chart? To do so, we use a modeling technique, a very specific modeling technique. This is called association. It's an association model. I can use either this one or this one. I'll just stick this one up there. I'll put karma in here, and the output looks very similar. And basically, that's going to turn exactly what we saw in the chart into a set of rules. It's going to uncover the same rules that we saw on the chart here. And I'm going to give it a few settings. I'm going to tell it to find rules which apply to at least 30% of the input and the output, 30% affinity. But it can go down to 8% of the data. And if I hit run at that point, what we find is that, oh, hold on, I probably got it the wrong way around. Hold on, click OK. Yeah, sorry, I got it the wrong way around. I want it to go down to 8% of the data, and I want it to be at least 30% true. It gives me an error there saying, I can't find rules that apply to 30% of the data. You have to go down to much smaller subgroups, and that's if I say run here. You can see that what it does is it creates a nugget. Okay, so this is one of the things that's sort of unique to Modeler, really. It creates the model as a physical object. There is your model. It's a physical object. It might be a good model. It might be a bad model. But it's a physical object, and there it is. And we can pour that object. We can use that object and connect it up to new data and pour new data down through it in order to create some of these new fields that we talked about. So before we do that, let's have a little look inside the object itself. If I go inside and hit Edit, you can see that the object appears inside. The model is shown as a series of rules, and the rules are called consequent and antecedent. Okay, so these rules are called consequent and antecedent, just ignore that. That just means input and output, really. All that means is if you have electricals and gardening, then you probably have home office. And we saw that in this relationship earlier on, which is just basically being shown up here, which is, if you have electricals and gardening, you probably have home office. There's electricals and gardening. If you've got electricals and gardening, you probably got home office as well, because this is a three-way relationship. That's all it's showing. Okay, so nothing terribly clever there. What it's saying, though, is that 17% of the data have electricals and gardening in the data set, or have purchased that within the last 6 months. And off that 17%, 87% of the time, they also purchase something from home office at some point over those 6 months. So this is a way of us identifying strong relationships, higher than random relationships. And down here, for example, we have a relationship between living room and textiles, as we expect, saying that 31% of the data have purchased something for the living room. And when that happens, off those 31%, excuse me, about half of them have purchased something from textiles. Now, there are other measures we can put in here. We can say, okay, well, show me the number of cases that actually relates to. Remember, this is only 1,000 cases. I've run this on things like 300,000 cases. And one example was when a rule came up which had a confidence value of 99%, and the antecedent and consequent were in fact codes or product ID codes for different products. So I had to go and look up the products, and it turned out, because it was a women's clothing, that the antecedent and consequence were in fact bikini bottoms and bikini tops. So that made complete sense. Sometimes it just finds obvious relationships. But everything beneath that would have had a confidence value lower than that, and it may well, in many cases, pointed out, clothing items that tended to get purchased together or tended to get purchased by the same sorts of people over a period of time. So here I have the instances. If I ask for extra information, I can say, well, give each of these rules an ID number and sort them by confidence. But there's another measure here which you hear a lot of people talking about, which is the lift value. And if I say sort by lift value, the lift value is really telling us that how many times are they more likely to have something in this consequent output given the antecedent compared to random. So basically, if 10% of the time when people buy, let's say, electricals, they buy something from, I don't know, the home improvement part of the store, say 10% of the time. If we find a situation where, 20% of the time they buy, if they buy electricals, they buy something from the home improvement store, then compared to the baseline, that means they're twice as likely to do it than random. Okay, so lift values above 1 are very interesting to us, because they're saying that they're more likely to have these consequences than random. And if they've got a lift value of 2, it means they are twice as likely to purchase this output, than random. They're twice as likely to do it. So lift values of 2 are very strong. And here we have lift values of 2.7, nearly 3 times as likely to purchase electricals and gardening if they've already got something from home office. So this is how we can interpret this model. But what does it physically produce for us? Well, all the way through Modeler, we have this preview button that we can use. And I can preview the data. And what we find is that the same data goes into the model, but now the model has created extra fields which weren't there before. So, this is what the model's creating. If we look at the original source data and preview that, you can see we get to the end. There's nothing at the end here. It's just ends at kitchen. Whereas when we preview it downstream of the model, it says the model's going to create these extra fields. Let's just have a little look at these extra fields in detail. And I'll put what's called a table node on the end here. And I'll hit run. And it shows me all of these extra fields at the end for all 1,000 records. And the fields are, in fact, have got $signs in front of them. That indicates that they are model fields. They're fields that the model itself has produced. And inside each of the fields, it has a recommendation for that case. So it's saying that for this case here, I recommend that the obvious thing to offer this person is dining, because, based upon their purchase history, there's something in that purchase history that means they are 52% likely to buy something from dining. And the rule that's firing it is rule number 10, which we can look back up here and find rule number 10. If I just sort by rule ID, I guess. I can sort by that. Says sort that. Find rule number 10. Can I sort by? Maybe I can't. I would need to search for rule ID and say okay. Say include. You can see here I can say lift or something like that. Then here we've got rule ID. There it is, number 10, saying if they got kitchen, then they should have dining, and that is why it's making that recommendation at that point in time, saying okay, you should offer them something from dining because they've purchased something in the kitchen history. So there we have, some rules have been fired there. You can see that we get to case number 5 here, and it says null. That's because this person simply hasn't bought enough products in the past to fire that rule. So for each of these cases where we have a recommendation that's been made, we could associate an image with that, or we could associate a campaign with that, and either do an outbound campaign based upon this, or on an inbound campaign when they call into the store, they ring up the call center, these recommendations could be fired, or when they go onto the website, we're effectively making next best offers here. It's a very simple way of doing it. And in fact, of course, we find that for most cases we have more than one recommendation we can make. For this one here we have living room, where it's a 31% chance they'll go for that. Down here we have electricals, textiles, home office and electricals. Some of them we only have one recommendation for, some of them we have 2, some of them we have 3, and we can include more and more as we're going along. Very common for retailers in this situation to look at the recommendation and to look at the probability value which is being created here, which is the likelihood that they would go for that particular offer, and multiply the probability by the margin, the amount of money that they're making on that particular product. Maybe they have a higher margin with textiles than they do with dining, for example, in which case multiplying that by 0.49 may elicit a higher profitability, estimated profitability, than multiplying something by 0.52, even by 0.6, and they'll make a choice based upon that. But that's a very simple model there. All I did was I ran my web plot. It give me some sort of indication as to where the strong affinities are. Then I attached a little node, a little modeling node to this called an association node, and it created a model for me. And that model then, by pouring the data down through it, created recommendations for me. And we could then use these recommendations. We could then export these scores back out to a database, for example. Here, it could come in through the database, and we could put it back out, and we could call it, affinity scores, I guess is what people often call these things. Yes, let's type right, affinity scores. And we could, we could generate an input node for this, or we hit run at that point. It'll go and create that for me. And it just goes and creates that. You can see it's actually creating a table called affinity scores for me in a database, which I might then use or call from, a campaign management system, or for a website management system where we want to, pick particular offers that we can surface when individuals come and visit that website. So the thing that's kind of particular and special about this particular example is the fact that there was no one target field, there was no one thing that we were interested in. We're kind of interested in the relationship between all of these fields here, and there's no one particular one that we're interested in. We just want to see the affinities. But there are, of course, situations where there are particular things that you're interested in, particular outcomes that you're interested in. So I've got another example here which illustrates that. And this is much more formally within the predictive modeling realm. Again, it's a database called Home Goods, but this time, although we've got a lot of data that we can work with, we've actually got a key field. So you'll notice that this time here, when I look at the data audit node, which gives me an overview of the data, we've got these little flag fields, as they call them, trues or falses, where people purchase something in furniture, kitchenware, or bathroom. But down at the bottom here, we've got this key field, which is called voucher redemption, and this indicates, whether or not people responded to an offer and redeemed a voucher. And believe it or not, for a lot of retailers, this is quite important, we're trying to estimate who is likely to redeem a voucher, a particular type of voucher, compared to others, because it's effectively an offer that you're making, and you may have more than one type of offer. You may have more than one type of voucher. So matching the correct voucher to the correct person is important, particularly as it's a stimulus for them to do more business with you. Now, this little data audit node is quite useful because it helps me identify fields or measures which are quite important with regard to estimating people's likelihood to, in this case, redeem a voucher, or fields which are strongly related to our key outcome field here. So the key outcome field here, just to emphasize the point, happens to be voucher redemption. It could have been customer churn. It could have been creditworthiness. It could have been, likelihood to recommend us to a friend, or visit the store again within 2 weeks, or visit the website again to make another purchase. It's some sort of key thing which is important to that line of business in the organization. In this case, it happens to be voucher redemption. But when I look at things like age group here, and it's colored by people who redeemed the vouchers, where green means that they redeemed the voucher and blue means they didn't, you can see that the younger they are, the more green there is within each of those groups. And that's really telling me here that whatever this voucher is, this particular voucher, it really appeals to the younger age group. Okay, so that's kind of interesting. We want to try and predict. We want to create a number, a score that predicts, who is likely to redeem this voucher. And we're going to use our historical data here. And our historical data here has recorded, of course, and again, I'll just put a table node on the end here. It has, of course, recorded from the past who has redeemed the voucher and who hasn't. And we're going to use this historical data where we know the outcome to build a model so that we can apply it to new prospective customers or new customers where we're going to make the offer, so that it can identify, who we should offer this voucher to. So when we do that, there are lots and lots of different algorithms we can use, and there's all these different bewildering array of algorithms we can use. And the other thing is that when we build a predictive model, it's very common that the model works very well on the sample data that you've given it. This is the sample data here. We've got 43,000 records. But when you come to applying it in the real world, it doesn't apply so well. It doesn't work as well on real data. And this is called overfitting the model. It means it's when it's too specific to the sample data. So one of the things that analysts do to get around that is that they partition the data. That means they split it into two groups. So if I just take a copy of this table node here and put it downstream this partition node, let's look inside the partition node. You can see that it's going to create two groups, training and testing. It creates them randomly. There's a random seed here, so we'll recreate it at the same place. It splits the data 50-50, so about 50% of the data is going to have the label training, and about 50% of the data is going to have the label testing. And we can illustrate this because we click run. Here's the same data set that we saw earlier on, but at the end here we've got training and testing randomly put in. So this case here is a testing case. This case here is a training case. So what we're going to do is we're going to build a model using only the training data. This is only the data where we know the outcome. We're going to hold back the testing data. It's not going to see 50% data. And then we're going to apply the model to the testing data to see how well it did on records that it didn't see originally. So it gives us a better estimate of how reliable that model is. Okay, but which model are we going to choose given the fact that we've got so many different types? Well, again, one of the tricks we have is we can go to the modeling types here, and we can call it what's called an auto classifier. That is a modeling technique where it's going to try all of the relevant algorithms, all of the relevant techniques, and it's going to make them have a competition with one another. It's going to make them choose, let's see, the top three best models based upon their lift value, or I can say based upon overall accuracy, or based upon other measures of fit. Here in the expert setting, here are all the models it's going to use. And it's basically going to, as I say, it's going to have a competition, say, all right, who does the best job at predicting the outcome on the test data, on the data that we don't expose to it. So it goes and builds a model, and then it applies it to the test data and says, how well did I do? And if I look at the little report up here, you can see it's building up to 10 models. One has failed to complete because there's something wrong with it. It doesn't like it. But there's another 10 models it's got to do. So now it's finished that. It's found the best 3. We don't know which algorithms or which modeling techniques it's chosen. But again, it's going to create a nugget for us. And when we look inside the nugget, we'll see the top 3 models or top 3 techniques or algorithms, depending on the term you prefer, it has chosen. If I look inside it, here are the top 3 techniques. It's chosen a decision tree type called C5 and a slightly different version of that, which it's calling C52, and it's chosen the classical statistical technique called logistic regression. And it's telling us how, how overall accurate they are based upon the testing data set. I can say, well, how well did you do on the training data set? And it tells me how well it did in the training data set, but it's the testing data set. And this lift value that we mentioned earlier on is basically based on the top 30% of the data. It's saying, you know, who does the best job. Alternatively, if that's too hard to get your head around, you've got overall accuracy here. You can see they're all about 80% accurate, you know, about 79.9%. But what we don't know is where the accuracy is. We don't know, you know, if they're predicting everybody to be a redeemer or everybody to be a non-redeemer. That's why the little charts are so useful. If I double click on this little chart here, you can see that it actually shows me how accurate the model is. So here we have the colors represent the predictions and the categories along the bottom are the actuals. And here it's saying that, yeah, it's doing a pretty good job of predicting zeros, i.e. non-redeemers to be non-redeemers. There's a little bit of error. That's the bit of green in the model. There's a little bit of error. Some of the non-redeemers it thinks are redeemers because that's why they're green. Over here in the redeemer, the voucher redeemers group, it's actually doing a pretty good job of predicting them, but every now and then it gets it wrong, and there's some error in the model here, and it's saying, yeah, I'm predicting these people to be non-redeemers when in fact they are redeemers. So this little chart here is a very quick way for me to see how well the model's doing, and you can see that they're all doing pretty good. The other weird thing is it says use along here. Yeah, this is very interesting. I can either choose one of these models and say, yeah, I'll just have this one, and I can look inside it and I can see that this model that I'm looking at is in fact a series of rules that it has found, where it's saying, you know, it's a series of rules and it's saying, you know, if they have garden or outdoor and it's equal to 1, then I predict them to not be a redeemer. If they have drapery, then I predict them to not be a redeemer. And if they have not got drapery, then I predict them to be a redeemer. This is mode 1. And we can just keep unfolding these rules and unfolding them over and over again. It's going into deep subgroup to subgroup. And we can put numbers associated with this until eventually it says, you know, these people here, there's only 6 cases there. There's 249 cases here, of which 76% are redeemers. These are people who are in age group under 35, you know, who have not purchased lighting but have purchased bathroom and so on and so on. Alternatively, you can see this visually as what's called a decision tree. This is the model itself. And in fact, this is a series of decision trees. And if I zoom right out, it's the pattern it's found in the data. The first one here is 82%, next one 70%, next one 64%. It's a series of decision trees. So one model here is actually a series of trees. This one here is just a series of rules, it's not trees. And this one here is actually it's a statistical model with things like parameter estimates. It's quite, you know, it's quite a well-known modeling technique, an old statistical technique called logistic regression. Okay, what does this produce? When I hit preview at the top here, it actually produces a new field, a dollar field here, with a prediction and a confidence value for that prediction. So it says, I am, you know, I'm 98% confident this person is a 0. I'm 70% confident this person is a 1. I'm 84% confident this is 0. Where is this coming from? Well, each one of these models here produces a confidence value, a prediction if you like, and what it's doing is it's combining them all together as if they were judges on a panel, and every time it's presented with a case, it then makes an estimate as to whether or not that case is a redeemer or not, and the probability is a kind of combination of them all. This is called an ensemble model. You can see that this first one here was in the testing case, so the model didn't see this case originally. It's just produced a score for it. It didn't see it when it was being trained, when it was being built. Only those marked training are the ones it's seen. There are other things we can do here. I can right click and say, look, I'm just going to use the top one. I'm going to switch off the other one, so I'll just use the top model here. So maybe that's better. And I can connect it up and show you what it produces. Of course, we have a whole bunch of scores that are produced here. You've seen this here. It's for 43,000 records of different scores, of levels of confidence. Here's the prediction. We want to compare how accurate that model is against the actual outcomes. And if I use this little analysis node here, it gives me a little piece of tabular output here saying that, well, on the training data set, I'm 79% accurate, and on the testing data set, I'm 79% accurate. Now, in reality, this is sample data. In reality, we'd usually see, I don't know, maybe a 5% difference, maybe a 10% difference between training and testing groups, just because of the fact that, you know, that it didn't see the testing data when it was building the model, and it generally tends to be much better on the training data, or sufficiently better on the training data for it to make a difference than it is on the testing data. But here, if I look at the testing sample here, which is about 50% of the data, you can see it's 21,513 in the training and 21,648, roughly 50% in the testing data. It's saying off those 21,648 records, it correctly predicted the zeros 10,000 times, 10,388 times, but it mistakenly predicted them as ones 1,800 times, maybe let's call it 1,900. Here it's mistakenly predicted ones as zeros because it says rows show actuals, so these are the actuals. Mistakenly predicted ones as zeros 2,400 times, but accurately predicted them just under 7,000 times. So if we were just basing it upon this model here, if we were just using this model and we're going to offer this voucher, we'd be offering it to about, if I add up 1,800 and 7,000, let's say under about 9,000 people, of which we would expect 7,000 to redeem the voucher, and we would miss 2,400 out. So it's really a judgment, it's a business judgment you make about, well, how many am I going to expose this to? And one of the ways we can make this judgment is we can use a chart called a gains chart. And here I have a gains curve. This is a graphical representation. And it's a very easy curve to get your head around. First of all, we're just looking at the redeemers. We're just looking at how well it predicts people who redeem the voucher. We have a red line, and we have a green line and a blue line, and we have two groups. We have the training group and the testing group, just to keep it fair, because there might be a big difference between the training and testing in terms of its performance. And what it does is it shows what the model would look like if it was perfect. That's the blue line. So it's saying if it was a perfect model, I could get you a gain of 100. That means I'll get you all of the redeemers, 100% of the redeemers from 44% of the data, because 44% of the data is made up of redeemers. Yeah. If I was using a completely random approach and just randomly trying to choose cases, then I could get you about 50% of the redeemers from 50% of the data. 50% off the redeemers from 50% of the data. So it's actually randomly selecting it. But the model is the green line, and it's saying, well, look, I can get you about 75% of the people who redeem the voucher from about 40% of the data, from about, about 74% from 40% of the data. So that tells me how much better it is than random and how much worse it is than perfect. And it's a nice way for me to compare the two. And in fact, if I add more models in here, we create more and more curves across the top. And it's a nice way for us to compare one model to the next. In this case, we're just using one model. Okay, so what happens if I wanted to just choose one of these algorithms or use the whole thing? If I want to choose one of the algorithms, so I double click on it and go, yeah, go and generate a little model for me. It just pulls that out and it creates this model for me. This is the same model that's in there. I've just pulled it out. But now I want to apply it to data where I don't know the outcome, where I don't know the result. I want to, I wanted to actually make a prediction into the future. Well, that's really easy to do. I just copy and paste that model and I apply it to new data. So I've got some new data down here called scoring vouchers. These are called voucher prospects. And if I just show you the preview button, if I hit preview button across the top here, it's for a particular campaign, happens to be the October campaign. And if we look across the top here, what we notice is if we look across the top, there's no field in this data set saying voucher, redeem, yes or no, because it hasn't happened yet. They haven't been offered the voucher yet. We don't know if they're going to redeem it. The job of the model is to tell us that. So if I attach the model to this, and tell it to show me the propensity value, show me this number that's creating, just to remind you. If I look inside the model, it actually tells me what are the most important fields in the model, which is very useful. It shows me the prediction. This is a dollar prediction. This is the propensity value. This is the probability of people redeeming the voucher. So, you know, if they get above 0.5, then they get a value of 1. If they're below 0.5, they get a value of 0 because they're greater than 50% chance that they redeem. So here, this one's got an 82% chance of redeeming the voucher, so hence it's categorized as a value 1 for redeeming. And I can chart that. I can say, well, show me that as a little chart. Here it shows me as a little chart. Here's the, you know, the people with very low likelihood of redeeming, the people with very high likelihood of redeeming. And I could say, well, okay, let's interact with that chart. And I'll just select everybody, let's say, above that point there. Because let's say it's a really good voucher, and I need to make sure that they have at least a 0.6% chance, sorry, a 0.6 probability or a 60% chance of redeeming it. If I right-click on that and say, generate a select node, then it will create this little node that says, okay, everybody downstream of this selection has at least a 0.6% chance, and I can clean it up a little bit. So again, it just makes it much easier for me than typing in the value. I can just visualize it. And then I can connect this up, and I can say, well, okay, create a new table for me in a database, and this table is going to look like this. I'll just show you what it's going to create. It creates the card ID and the propensity that they're going to respond to the model, and everyone's got a propensity greater than 0.6. And I've just used this little filter node here to get rid of all of the fields in between, because of course the people who are making this campaign selection, they don't need to see all the fields in between. They just need to know the customer ID, and they need to know the propensity, so that they can make sure that they're selecting people with a high likelihood. And here we've got 16,000 potential candidates for this who are very likely to accept this voucher, because we've built a model against it, and we've tested the model to see how accurate it was on a test sample. Now we're applying it to some real data where we don't know the outcome, and it goes and creates that table in a database. And in fact, if you had very sharp eyes there, you'll notice it actually turned purple when it did that. And that's because if I'm using Modeler Server, and I've got a server copy here, it actually turns the entire stream into SQL. Let me see if I can show you where that appears. Let me just switch on logging. If I just say reformat, just run that again. If I press this little button, this is the SQL preview button. So it turns it into SQL, and I could paste that into the database and run it. But really, what's happening in the background here is I don't need to paste it into the database. What it's doing is it's passing this entire stream to the database, so that the data never leaves the database. It's created SQL for it. So I'm not dragging this data across the network and then scoring it on my copy of Modeler. I'm actually getting it to create SQL that then hands it back to the database, and all of the scoring is done inside the database, which is a very powerful way for us to make our analytics scale. And this is called SQL pushback. Okay, so we're coming up to the top of the hour now, and that's pretty much all we're going to show you. I hope you find that useful and illustrative of how Modeler works and some of the nice aspects of interacting with the data. Again, why do people use it? Well, it's fairly easy to use, fairly intuitive. It's very scalable. It's easy to integrate with output. It does support standards like PMML, which is a type of XML, a way for me to wrap up models and put them into other systems, and direct integration with open source statistical tools like R. It supports SQL pushback. We can also call algorithms from within the databases themselves. So if the databases already have algorithms, like Netezza has algorithms, I can call them from within Modeler. DB2 has some analytical algorithms, and Microsoft SQL Server Analytical Services has algorithms. Infosphere has algorithms. Oracle has algorithms. So I can actually use these alongside my existing algorithms. I can, in other words, harness the power of the database. And it enables things like text mining, which we haven't had a chance to cover here, but which we have a video of on our website. There's some other aspects to this. I've just added it in the architecture slide here so that when you get the PDF sent out to you, you get a sense of how it works. I've just been using a client copy But you could be using a client-server environment, and you could be harnessing SQL pushback so that all the processing occurs either in the data warehouse, because it's all getting pushed back as SQL, or it's occurring on the modeler server, or it's occurring at the client level, or potentially occurring on a deployment platform. There's actually another server, it's called the analytics server, which is the big data server, for Hadoop and that sort of thing, and Spark, which IBM uses. So it's a very flexible architecture, very easy to to scale it up. Most people are just using client copies of it because it's actually pretty good at working on the desktop. Okay, so if you want to find out more information, go on to our website. We've got lots of information on there about various SPSS products as well as SAS products and Blue Sky Statistics, but there'll be quite a few videos on there that we've created about SPSS Modeler and some downloadable content as well, which is coming on stream. In the meantime, with regard to working with us, well, we're a premier partner, so we can sell the software directly to you. We're expert providers of IBM SPSS. And that means that we deliver things like training courses, we offer skills transfer, we offer consulting. We also run booster and refresher sessions if you've already got the technology, and we offer telephone support. We're a technical support providing partner, so we can offer technical support, telephone support, and how-to support, not just error messages, but give you some sort of advice so that you can get moving quickly. In the meantime, I hope you found that useful. As I say, we will be sending out the slides afterwards, so you'll get a copy of this, and there will be a recording of the session if you need to revisit it at any point. In the meantime, have a great weekend, and we look forward to you logging in again at some point in the near future. Bye-bye.